everyone, it's Sandra. I'm out here with my worm cafe, and I'll put a link to the last video I did where I'm trying to increase the microbial and biodiversity in the bin, because I started it off with a lot of coconut coir, which you know doesn't really have any inherent natural microbes to it because it comes in a compressed dried form. And in walking our neighborhood, I happened to see these. These are from cottonwood trees, and again, because of our summer dry conditions, they're falling dry. And I thought, I've never vermicomposted cottonwood leaves, and I've also never composted them, so I thought I would try them out in this system. And just to make it interesting, I picked up some dried maple leaves from across the road there, and I'm going to do a head-to-head with red maple leaves and cottonwood leaves. And I'm going to talk to you a little bit about cottonwood trees because I did a bit of digging before I did this video, and tell you what I found. All right, let's get into it. Okay, so I'm out here with Itzy, and the first thing I notice is look at how much the level has dropped in the feeding zone. The last video I talked about how coconut coir does not seem to process down as quickly as natural beddings. So I've been adding natural beddings, and look at them drop. Wow, that's in comparison to this end of the bin that had more coconut coir. And look at the presents that worms leave you on the top of the bin. It's a nice cocoon. All right, let's first start turning over this end before I get into the feeding zone. I'm just going to talk to you a little bit about what I found about cottonwood leaves. Now, all leaves contain lignin, which is a polymer that gives leaves the structural integrity, basically makes the leaves and the stems rigid. Just trying to open this pit. Even if you give it a little tiny dent like that, the microbes will get into it. I'll put it in the feeding zone. Well, I might feed over here. We'll see. And so cottonwood, no exception. The issue is that the amount of lignin, I found a little worm over here. They must be hungry. The issue with cottonwood is that it varies widely how much lignin is found in the leaves, from like 5% way up to, in the high 20s. Percent of the leaves. And of course, lignin is going to determine how quickly leaves will decompose, both in a vermicomposting system like this, as well as in regular composting. Now, the cottonwood leaves also contain tannins, and I'll put a link up to my video that I did recently on tannins in worm bins. And tannins kind of work with the lignin in leaves to make them resistant to decomposition. And so I'll be curious, I'm in a neighborhood that has a lot of cottonwood trees, and am I going to put these in my bins and my composting systems going forward into the fall? Well, yes, but I want to sort of compare them. I also have a choice to put maple leaves in the system. So I would like a choice. How do they decompose? If I need faster decomposing, would I add maple leaves or would I add cottonwood leaves? Now, of course, with any leaf, if you shred it, you're going to get faster results. Interestingly, in head-to-head, the digging I did on the internet said that vermicompost systems are going to be 2 to 5 times faster than regular composting when it comes to breaking down cottonwood leaves. So, if I want to turn those leaves into a lovely, rich resource for my garden, I'm a lot further ahead if I put them in my worm bins. That is because of things like this, the chewing action of these pill bugs, which of course are in compost as well. But as soon as the pill bugs have chewed up the leaves, the microbes can act on them, and worm bins have microbes that are not found in conventional composting systems. And they also have enzymes in their gut that can break up leaves faster than a conventional compost. And that, that's really surprising, because when you think of it, a conventional composting system will have a thermophilic cycle. It will get super hot. Okay, I'm not going to squeeze that pit because I see a little baby worm on the outside of it. So, they get really super hot. And so you would think, well, they would break up leaves faster. And it's actually not the case. It's not the case with cottonwood leaves anyway, and that's what I looked into. There's my old Starbucks cup. The worms have taken care of everything except the paper on the bottom, and just leaving me with this plastic wrapper now. All right, so this end is looking pretty biodiverse. I am not seeing that characteristic red rust color of unprocessed coconut coir anymore. I'm not saying it is finished vermicompost by a long shot, but it is certainly looking healthier in terms of a diverse worm bin than it was in my few last check-ins, when I still had a lot of the coconut coir type texture and observations. Is that plastic? Yep. Must be off a mailer or something. So let's go into the feeding zone. So yeah, so do you compost cottonwood leaves? Do you shred them first? Do you put them in your conventional compost bins, or do you put them in worm bins? They also, like I said, have a high tannin content to them. And so, if you look at my video on tannins, you'll see that tannins need a specific microbe to break them down, and worms will not approach the area with high tannin elements until the microbes have started to break those tannins down. So it's not like they will harm the worms, but the worms will avoid the area. And obviously these are protective mechanisms that the leaves have, so that they are not subject to microbial breakdown. Should they get damaged or whatever on the tree, the leaves are slightly resistant. And so it's not surprising that that carries forward even when the leaves have fallen and we try to compost them down. All right, so I'm just putting the bigger chunks here. Now let's turn over the feeding zone. Oh, there's a cherry, I think. Yep. Now if there's a pit in the middle, it's a cherry. Yeah, I think that's an old cherry. There's another thing that's resistant to microbial breakdown. Okay, so let's turn over the last feeding in trying to bump up the diversity of this bin. I'll take my glove off. I put some natural, some of my fuchsia flowers and natural bedding in here. Let's take a look. And then I know why the worms were browsing everywhere. I poured watermelon juice everywhere. So here you see those maple leaves I added last time. And there they still are. Last time, by the way, was about 20 days ago. So here are these maple leaves. They're obviously wet through with the food juices that largely came from watermelon. Yeah, I am definitely getting a lot of leaves building up in this bin. The worms are in here. Now this is a tiered system. This is Itsy, the top level. And these juices that I'm seeing, see how my hand is getting not sticky, but certainly vermicompost sticking to it. That means this end is running quite moist and probably dripped through a lot of those yummy juices down to the bottom layers. Don't have land in here to dig down today, but when we do that, oh, and look at the compressed castings on the bottom. Yeah, look at that. Gee, if you wanted to harvest, you could just peel them right off the bottom there. Wow. Anyway, I'm sure because of that watermelon juice, they have dripped down through the lower levels. And so the worms are not only follow moisture, they're going to follow those watermelon juices. So in terms of cottonwood, the research sort of said that the higher tannin content adds to the resistance of the decomposition, but some cottonwood varieties, look at the castings that were underneath that, wow. Some cottonwood varieties have so little lignin in them that they should decompose very quickly in a worm bin. So this will be interesting because I've got, look at these, still got these maple leaves from last time. And there goes my Starbucks cup, that's okay. I've still got these maple leaves from last time, as well as some wood scraps. And I'm going to put some new maple leaves on top. There we go. And so obviously 20 days wasn't enough to even make a dent on the edges of those maple leaves. Now, if I shredded them, it would be a totally different story. And I'm in no hurry for this bin to harvest it, so I'm okay with waiting for these maple leaves. Probably won't take just one feeding cycle. It'll probably take several feeding cycles because certainly for these maple leaves, they are still resistant. They said the lignin content of maple leaves is, I think, like 17 to 24% or something, which is actually higher than I thought. I always thought maple leaves were lower than that. Anyway, let's get a little bit more food here and then we'll do the cottonwood side. Okay, so we've got a piece of watermelon, some cornmeal, give them broad interest through the area, and some spent coffee grounds, some eggshells, and also got some flowers from my hanging baskets again, some of my compost, and some decomposing leaves from Victoria. We brought all this compost and leaves with us, so it's breaking down. So I'll put half here because you need both slow and fast carbon. These decomposing leaves, you can see that they're mostly broken down, so the worms will be able to get into that much faster than those leaves that just fell this year. Okay, let's pull this over. There's a maple leaf right there, tuck it in the corner. And I'm going to do the same thing on this side with the cottonwood leaves. Thanks so much for hanging with me, everyone. I wasn't feeling well when I shot this video. I want you to notice how big a volume these tiered tumbleweed systems are. Far bigger than the worm factory, I think. Cottonwood leaves have this very characteristic heart shape. They are much crispier than the maple leaves, even falling onto the ground. And these stems seem a lot more brittle. They're like toothpicks. So that's an interesting difference. I fast forwarded through this side because of some neighborhood yard noise. By the way, cottonwood leaves I did find have a slightly lower pH than other leaves. They are down to like 4 to 5. And as you know, anything below 5 is fatal to worms. The worms are incredible neutralizers of pH. They have that calciferous gland. That's one of the reasons we put pulverized eggshell or pulverized oyster shell in a worm bin, is to help the worms replenish that gland and continue to neutralize the pH. All right, so this is our compost and leaf litter going in. Very well could be worms and or worm cocoons in there. Okay, so now we have a head-to-head of cottonwood and maple leaves, and we'll see how they do in my worm bin, and because I am going to be able to get a lot of these leaves going forward. Now I'm going to flatten this out as best I can. So these worms are going to have to choose which way do they go. All right, everyone. Thanks for watching. Bye for now.